Okay, let's pick up from where we left off. A little more detail on the different types of what I'll consider just standard data cable. We've got shielded twisted pair, STP, unshielded twisted pair, UTP, screened twisted pair, SCTP. Okay, and what's the differences? The most commonly used one is right here, unshielded twisted pair. It has 4 pairs in the cable. There's a sheath over the 4 pairs. Each pair is twisted, and then the 4 pairs are actually twisted around each other. No shielding, least expensive, probably the easiest to terminate of all. The next most common one that we find is this shielded twisted pair, and in that case each pair has its own shield around the pair. The pair is twisted, has a foil shield. Each pair has a foil shield, and then there is another shield that goes around all 4 pairs. And that shield gets terminated to our bonding and grounding system through the connectors, through the equipment chassis. So in that case, the shield is trying to eliminate noise from entering the cable. And by the way, it works the other way around too. It eliminates noise from leaving the cable. Screen twisted pair. I've installed a lot of that stuff, not typically for a data install. Some control systems will use that. Data systems in Europe seems to be the target for data with the screen twisted pair. So what's the difference between screened and shielded? Well, screened just has one overall shield over the twisted pairs inside the cable. So if we got a 4-pair cable, we'd have 4 twisted pairs with just one foil shield over the 4 pairs, and then the outside sheath around that. Again, helps with noise getting into or out of the cable. Categories of cables. Category 1, basic. We have conductors that are ran from point A to point B. Doorbells was a common example used. Early telephone systems used, usually it was 2-pair ran to the home, and very common, no twist to it, older style, not good for data at all. Category 2, now that one was used for some data. I never worked on those systems to any extent myself. I worked on some of the hardware, but never actually ran the wiring. I have terminated a token ring connector. It's a pain, big bulky connectors, large conductor cables. Again, out of favor. There's still some of it around, not a lot. Category 3, old data standard, slow by today's standards, 10 MIPS. Ran into a lot of that when I went up to the University of Wisconsin Green Bay campus. Had to actually work to get a couple of buildings upgraded to a category 6 level. That'll be on the next screen. Cat 4, can't say that I used a lot of that. There you see the reference to token ring, old IBM standard. A little faster, again didn't work with that guy much. Category 5, no longer an approved standard, 4-pair, twisted, no shield. Good for 100 megabits per second. Standard used in Ethernet, still a lot of it around. It's just no longer an approved installation standard. Cat 5e, pretty common. A lot of that going in. Current standard, a little less expensive than the next one. So good up to 1 gigabits. Typically can't run that fast, but that's what the table says. I've seen other tables that'll say, and that's probably more of an ideal condition where it can run that fast. Cat 6, latest standard, basically Cat 6, Cat 6A augmented, meaning it's just been enhanced a little bit. Faster than the other categories, certainly more expensive, bigger conductors, a little bulkier, harder to terminate. Category 7 is not an approved standard, and it is being used in Europe a lot. You can buy it, just not a current approved standard. And my understanding is the main reason why is that it's expensive. It doesn't give you that much more for the bang for the buck. It is a shielded data cable, okay, but no pressure to go to that. I think we'll actually see that category is superseded by like a Cat 8 or something, and we'll go directly from Cat 6 to whatever new standard gets established. Another type of cable, fiber optics. You'll get a chance to play with that a little bit. I'll teach you the safety first and then how to actually work with the cable. Now you'll be stripping it, putting connectors on, testing. Similar processes, but a different type. It's a glass-based cable, different layers. The core, very center, is glass. Next layer is the cladding layer. That's also glass, but the chemical makeup of the glass changes from core to cladding. Then we have this kind of a braided, well, it's actually called Aramid yarn. Kevlar is a brand name, but you should be familiar with Kevlar, Kevlar vests, Kevlar helmets. Pretty tough stuff. You'll get a chance to see that. Here we are sending light pulses rather than electrical pulses, so photons rather than electrons flowing. Okay. Two major categories for fiber: single mode and multi-mode. Single mode, outside plant, long haul. The stuff that comes up from Chicago or over from Minneapolis, St. Paul, your internet service is going to be running on single mode prior to coming to your residence. Inside plant, larger facilities, they're going to typically be using this multi-mode cable. It's not as fast, can't go as far, but still much faster than copper-based cables, and the multi-mode's less expensive, easier to terminate than single mode. Here's an image of fiber. Again, core made out of glass, cladding, another layer of glass. There's another layer over this, which is an acrylic layer that you'll be stripping off when we actually come to terminating the cables. Kevlar, here's that Aramid yarn that I talked about, and then we're going to have a typical jacket or sheath over the cable itself. Cable comparisons, you can see some of the references. ThickNet, older base systems, don't hear a lot about that anymore. Some of these guys are still in the Fox River Valley, but not that many. Reference to a vampire tab, kind of an interesting concept where they actually will penetrate right into a cable that's running through. They'll put a device on the cable, and you can see right here where it actually punctures the cable and hits the center conductor, so it's a coax based. And then we have another place where they will puncture the sheath of the cable, but it only gets to the shield. So we have connection to center and shield. That's our transmission path. Again, I haven't done this one, know of it, rarely used anymore. Reference on this screen, well, we do see the use of something called a BNC connector, used for coax cables, and the BNC actually comes from the name of the three engineers that developed it. I believe it's Bayonet, Nielsen, and Tunselman, close on that. But they developed this style connector, rugged, expensive, terminated hundreds of those. There is a new compression style BNC that makes it for a fairly fast termination. Again, more expensive, professional grade style connector, not the kind of thing you find in the consumer market too much. Here's a look at a BNC connector. Stick on and twist to lock it in. Like lenses on cameras where they'll lock in, that's a bayonet style. Okay, well, these will twist to lock in as well. You can see a center conductor, the outer part is connected to the shield. This device is simply called a T connector, which allows for a pass-through and then a drop-off for like the PC. Again, reference to a NIC card that goes into a PC, or right now part of the motherboards. Here again the acronyms, remember those? Shielded twisted pair, unshielded twisted pair, some of the speeds that they're talking about. Here's that screen twisted pair. Okay, some of the distances. And our standard in the industry, we typically use Cat 5E or Cat 6, unshielded twisted pair, and it's good for 100 meters, period, not to exceed. So that's kind of where the standards are. 8-pin RJ45 connectors, standard in the industry. RJ As I recall, registered jack version 45. It's got 8 pins, 8 conductors for our data cables. You'll get a chance to work with those, so don't worry about it if you're not sure what that exactly means. And hands-on will get you through that. Back to fiber. Fiber is our fastest type of cable. Okay, much faster than our copper cables. We can run long distances. Last time I talked to one of my trainers that certified me in fiber optics was they did a repeat at 75 miles from the transmit site. 75 miles before they had to regenerate the signal. Wow. That's a pretty long haul compared to other technologies. What did I just say about the Cat 5e, Cat 6? 100 meters. Okay, so yeah, fiber, long haul applications. Type of fiber connectors, ST, SC, oldest styles. A lot of these guys out there, probably the most common. Small connectors are now hitting the market pretty heavily. MTRJ, LC is another one that's a small form factor. I stock the LC, and if you want to look at that, just let me know and I can point that out. Here's a look at the ST and SC styles. ST, kind of that bayonet where you stick and twist it to lock it in. SC, stick and click. And just push it in, listen for the click, then it's seated. So, easy way to remember that. Alright, and the last slide. A little bit on the wireless technologies. Well, we'll talk more about that as we go on. Certainly we use that all the time now with our little Wi-Fi networks at home in larger facilities. They'll provide Wi-Fi. We've got free hotspots around the cities now. McDonald's, I believe, has free Wi-Fi. Other locations, sometimes you got to pay for it. So a wireless means of connecting and to a network. Pretty handy. Different speeds coming and different frequencies that they run at. Makes things a lot more convenient if you can get by, but note your wireless technologies will always lag your wired technologies in terms of throughput capabilities. It's kind of the way that they evolve over time. Faster and faster over copper, they're getting faster and faster over wireless, but typically wireless will lag copper in terms of its speed. I should say copper and or fiber. Okay. Think of questions. Ask me when we get into the open lab. Be glad to try to answer your questions, and that concludes this week's presentation.